Hello, Mr. Long. This is F4K6. For part A, we're asked to draw the free body diagram for the system. The system goes like this, and then boom, 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 boom. Alright, so there's four forces acting upon it. First, F of G, simplest one. Second, F of N, and now F of N, and now there's the F2F here. And the reason why this is 2F is because in this free pulley system, it goes like this, right? The string, right here is F, and right here is F, right? So this wheel, let's say, it has two F's worth of tension, right? And since this string that is connected to the block, it has an equal and opposite reaction force, this has to be 2F, right? And that is, oh, I forgot. There's also F of K, which is acting against the motion, and since it is saying that it's moving upwards, it is going against the line of motion, therefore F of K is pointed downwards. And one more thing, we'll be having the x-axis be this line right here, and y-axis be this line right here. Alright, so for part B, we're asked to derive an expression for the magnitude of the pulling force. So we're trying to find the absolute value of F. So the sigma x f of x is given by f of 2f minus f of gx and f of k. If I'm correct, yeah, f of k. And this is all equal to 0 because it says that is moving at a constant velocity, therefore acceleration is 0. Alright, so we can rewrite this as 2f is equal to fgx plus f of k. And here, fgx is equal to fgx has is composed of fgx here and f of gy, and the theta here is congruent to this one. Is it that one? No, it is, because if you think of this, no, this is this one, because this is theta, right? And this makes up 90 degrees, therefore this has to be 90 minus theta, and this makes up 90, therefore this is question mark, let's say, question mark plus 90 minus theta is equal to 180. These two cancel out. Question mark is equal to theta. So we found out this is theta, right? And theta, or not theta, and f of gx, as we stated earlier, this right here, f of gx, is the, if you draw like this, fgx and fgy, fgx is opposite to this angle, right? So therefore, sine theta gives us fgx, because that is opposite, over the hypotenuse, which is just fg. Therefore, fg is sine theta is equal to fgx. And fgy, similarly, is given by cosine theta, because cosine theta is given by adjacent, fgy, which is the adjacent, over fg, the hypotenuse, and fg cosine theta is equal to fgy. Now, we just, fgx just becomes, fgx, like we stated earlier, is fg sine theta, and f of k, which is given by f of n times mu k. F of n here is equal to f of n is equal to fgy. And the reason why is because those are the two only existing force, and it's not moving in the y direction at all. Therefore, it is sigma f y has to equal 0. And since this is also equal to fn minus fgy, because fn is acting this way and fgy is acting this way, these two have to be equal to each other. F of n has to equal f of gy. Right? So, as we found fgy earlier, fgy is f of g cosine, or f of n is equal to fg cosine. F of n is equal to fgy, which is equal to the cosine theta times mu k. Alright, and then now we can just do mass times gravity sine theta, because fg is equal to mass times gravity, and g cosine theta times mu k is equal to 2f. And well, we just divide both sides by 2, and we can I can do this because they both have mg, right? So I'm just grouping it together. sine theta plus cosine theta times mu k over 2. And that is the formula for f. Alright, for part C, we're asked to, if the angle of the ramp is decreased, then the magnitude of the applied force needed to move at the corner would. Alright, so using the same formula right here, okay, using the same formula, what do we see about, given that everything else stays the same, so here, m is still 0, we can still use this because m is still 0, right? And nothing else changes, aside from the fact that sine theta will increase. So, sine theta, okay, so if theta increases, what would happen to sine theta and cosine theta? Sine theta, if cosine theta decreases, right, sine theta also decreases, but cosine theta increases, right? So, what would happen, though, is that cosine, right here, if you look at it inwards, cosine theta times mu k is always going to be less than sine theta. And we can assume this because, what do you call it? Mu k is never greater than 1. Therefore, it's always going to be, always going to have less impact than sine theta because of the mu k. Because mu k is basically nerfing cosine theta. So therefore, since sine theta is always going to be greater than cosine theta and mu k, this is sine theta is the thing we will mainly focus on. So when theta decreases, and since sine theta decreases when theta decreases, we can just say that as theta decreases, sine theta decreases. I mean, I explained this, so I'm just gonna say as theta decreases, f would also decrease. Magnitude of f would also decrease. I explained this, so I'm not gonna write it all out. All right. So for part D, we're just calculating f, right? Yeah, we're calculating f, right? But here, we can use the same expression, right, we found up here. The reason being is that here in this problem, f of x is equal to, sigma f of x is equal to 2f minus f of g minus f of k, or fgx minus fk, is equal to mass times acceleration, where mass is equal to, acceleration is equal to 2.1. So 2f minus f of gx, and all this, which is equal to fg cosine theta, sine theta, minus fg cosine theta times mu k is equal to mass times acceleration, right? So I'm just gonna move these two values to the other side to do mass times acceleration plus mass times gravity times sine theta plus mass times gravity times cosine theta times mu k is equal to 2f. And I'll just divide both sides by 2. I'm getting, right? Alright. And we can just plug in the values now. So mass is 5 times acceleration, which is 2.1, divided by 2. I'll just do that later. Plus mass 5 times 9.8 times sine 37. Plus mass 5 times 9.8 cosine 37 times 0.24. That is like 37. All over 2. And this gives us, let's see, 5 times 2.1, 10.5, 5 times 9.8, 49, times sine 37, plus 29.48, 8, 5 times 9.8 times cosine 37 times 0.24 plus 9.39 all over 2. And that gives us the value, boom, 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 divided by 2, is equal to 24.69. So 24.69 newtons is the force when the applied force F is 24.69 when it is moving up the block at a constant rate of 2.1. All right. So for part E, Do I have room? Yes, I do. Alright. Part E, we're asked to draw the free body diagram of the new system. So now we have the block M, and this is the same as they're just FG, Fn, 2F. However, there's another one, F of M times M, the contact force between the two blocks. And for the big, or this is like, contact force, yeah. Right? And then for this block M, for block big M, we have the force Fg, similar to the small m, F of n, same thing. But now we have the static friction force, right? Which goes against the line of motion. Yeah, that's it. All right. So yeah, because F of S and F of G are the only thing. Yeah, and F of S is against F of G. Yeah. That makes sense. All right. For part F, a second block of mass m equals 3 is placed on the okay. Was a minimum force applied to keep the system at equilibrium? All right. So we're trying to find FF, absolute value of F. And what we know about absolute value of F is that what we know about this this question is that sigma f of x is equal to 0 because it says it's in equilibrium, right? And what do we know about f of x? It is given by 2f minus fgx minus f of k is equal to 0. However, here we're basically doing the same thing as the problem earlier. However, the difference is that I'll just skip to the mg, so f of g is given by not just m but m plus m, because the entire system is the entire block is there's two masses now, right? So it's just m plus big M times g times sine theta, this should be x, sine theta plus mass plus big M times g times cosine theta times mu k. I almost forgot that. Over excuse me, and we'll divide both sides by 2, and then we'll just plug the values in. 3 plus 5 g times sine 37 plus 3 plus 5 times g times cosine 37 times 0.24 over 2, and that gives us the value. I'll just skim through that. 8 times 9.8 times sine 37 plus 8 times 9.8 times cosine 37 times 0.24 divided by 2. That gives us 31.105 newtons for F. The magnitude. Alright, and then you have to absolute value both sides. Yeah, and then, I mean, it's positive, so it doesn't really matter, right? Alright, so for part G, our last question. Alright, we're asked to calculate the minimum coefficient of static friction. You have to keep the block stationary. Alright, so we have to divide this into two parts, for block M and for block big M. So for small block M, we'll do F of mx, and then we know that this is 0, right? Because this states it's an equilibrium. Same for the big M is equal to 0, right? So what we know about I mean, you don't really need to know about the small m. We just need to focus on the big M right here, because big M is given by f of s minus f of g, or it doesn't matter which way it goes, because f of g, f of n, well, basically they're equal to each other, right? It doesn't matter if which one's negative, because they're equal to each other, right? Because it's equal to 0. So f of g, fgx, can't forget about that. Fgx is given by, or f of s is given by fgx, which is equal to mass times gravity times sine theta, right? And here, it should be big M, right? M is given by 5, or is it 3? 3 times 9.8 times sine 34, because they're on the same block, right? like if it's like this, right? These are just gonna be the same because they're parallel to each other. The thetas will be the same because they are parallel to each other. Yeah. So times sine 34, and that gives us the value of 17.69 newtons. And what we know about Fs is that Fs is given by f of n. Fs is given by f of n times mu k, right? Or mu s here because it's static friction. And right, well, I should put n's here, right? And f of n is, as we stated earlier, is similar to what we stated earlier. F of n is just given by f of gy, and this is because f of gy and f of n are the only two the y-axis values, right? So f of gy is equal to f of n. And what do you know about f of gy? It is big M times gravity times cosine theta times mu s is equal to 70.691 newtons. So what do? We divide both sides by what was this? Oh, that's mass. Sorry. So we just divide both sides by mass g cosine theta. Oh, let me plug those values in real quick. 3 times 9.8 times cosine 34. Is it 20? 37 times mu s is equal to 17.69. So I divide both sides by 3 times 9.8 times cosine 37. 3 times 9.8 times cosine 37. And we're left with mu s is equal to 0.7534. That's a constant. Yeah, because I should not be putting newtons there. What am I doing? Yeah, so that's it for this video. Thank you very much for watching, and have a great afternoon or night or evening, whatever.